Hello, and welcome to a series about TDD as if you meant it. This will be the first episode where I will start working on a very small problem, naming the tic-tac-toe game, and showing how TDD as if you meant it works out. Because I want to have a kind of a pace and I get carried away with coding, what I will do, I will have a Pomodoro, so whenever this time runs out, I will stop the recording whatever I do, and then this will be the first episode, and then we'll go on with the next ones. So let me start the Pomodoro and let's do some coding. I have here an empty Java repository. I will explain you how TDD works, and especially how TDD as if you meant it works. First of all, I want to make sure that I have a good setup, so I will create a class. I'll call it tic-tac-toe tests, and I want to create a test. It's not that important what it does. Just want to make sure that JUnit works fine. And I need to import this. Now I'm running the tests. It's red as I want it to be. I want to make it pass now, so everything works well. Now this is the first thing I always do, just to make sure that I have a good setup for my test environment. Now let's begin explaining a bit about what TDD as if you meant it is, and I will also explain some other details that aren't in the rules. Now, TDD as if you meant it was created as a, let's say, coding game by Keith Braithwaite, and you can see now on the screen the rules. Basically, the rules are saying that you're not allowed to create any new classes or new methods. The only thing that you can do is write the production code in the test method that you're writing here in the test class, and whenever you spot duplication, you are allowed to remove that to another method, and then when you see more methods that belong together, you're allowed to extract them to a new class. Now, these rules may sound weird, and we'll see where we could go with these ideas. Typically, what happens is that I have full test coverage because all the tests are written for the production code, and also I have the minimum amount of code needed for that specific solution. So let's see a bit more than just the rules that you just saw on the screen. Typically, the TDD cycle is red, green, refactor. So red means I add a test that's compiling, but it's not working, as you saw with assert equals 1 and 2. It's obvious that won't work. Green means I write the minimum amount of production code to make it pass, and then refactor means that I will do the necessary changes so that the code looks nice. I don't have duplication. I have nice names for everything around. I have a good structure. I respect my coding standards and anything else that I need to do. But what people are often forgetting is the think part. It's not about just starting to write tests. It's also about doing a bit of analysis. Now you can do this in your head if you've done TDD for a long time, but also you can just write it down. So I really recommend it to write this type of analysis down and to understand how what you need to do next. My first guideline is always start with outputs when doing an analysis. What do I mean by that? Well, especially with the TDD as if you meant it, we will focus on writing state tests. So we care only about the state of the system, and we don't care about interactions, so mocks and things like that. Because we have state, it's clear that we'll have a clear output of the system. So I know the output because typically any client comes and says, look, this is what I want. And because I know the output, it's very important for me to understand which are the possible inputs for that specific output. It's a lot more difficult to start the analysis with the inputs because the inputs can be infinite, but the outputs are never infinite. Or not never, but almost never infinite. And anyway, I can get examples from my clients saying, look, this is what I want, even though the outputs would be infinite. So for that specific outputs, I can generate some inputs. So I have my tests, because as you see here, any test has an expected and an actual. The expected is the output I expect from the system, and the actual is the output I get from the system. This happens in a specific case when I have a particular input. So that's why I want to make this kind of analysis. So let's do this. I have tic-tac-toe game, and tic-tac-toe has some rules. It says like that: X plays first and 0 plays second, and then I have some possible results. The results could be x1, 0, 1, or it's a draw. So if I look from the outside, these are the possible outputs of my system. I want now to think about which tests I can write. So x1, this is a possible result. What are the possible inputs? Well, there's another rule here. The fact that we have a 3x3 board. So it's clear that X wins in some specific cases. We know that the possible win conditions for any player are win. So we could have a column, we could have a line, and we could have a diagonal. Conditions. conditions. So these are basically the rules. If I have these possible outputs, I could start thinking, when could this happen? So I make like a table and say inputs, outputs, and I start with the outputs. So if the output is x1, then the possible inputs could be that we have x finished line, then x finished column, and then x finished diagonal. Let me arrange this a bit. This is the type of analysis I typically do. We call this behavior slicing. Why? Because what you're trying to do is to slice the behavior of the system, and you start with the outputs, you look at what these are, you try to get examples from your client, and then with the help of your analysts or clients or whoever knows the domain, or maybe you know it and it's very easy for you to do this, you start understanding the inputs. Another thing that I want to do with TDD is, and I will write it with big letters, simplify, and an exclamation mark. We try to simplify the problem as much as possible, and we want to start from something that's very basic, even weird, stupid, and to grow it towards that case where the client really can use this. So I need to think now, how can I simplify this? Typically, what I try to do is to reduce the game, to reduce the problem, to reduce some parts of it, and in a way to ignore it. One way is, as I've done this analysis of the game, I need to look at all of these, right? One way to simplify it is just to look at the board and say, instead of having a 3x3 board, what's the simplest board possible? It can be a board that's 0x0. That would be weird, but I can try it because I would simplify it a lot. Or 1x1, which makes sense in a way. I could say I have only one player instead of these two players, and yeah, I don't care. Another thing I could do is just say X always wins. So simplify again. And here, what happens if I would do, let's say, a 1x1 board, column, line, and diagonal are identical, because I don't have 3 directions. Only when I have at least 3, this would make sense. Oh, no, at least 2. So this is very important. Try to simplify. While simplifying, I'm looking at a thing. I'm looking at this thing. So it's another guideline. Let me put this here as well as behavior slicing. And oops, and here as well. Another guideline I'm using is introduce only one notion at a time, one per test. What do I mean by notion? Here I have these notions: board, x, 0. Probably x and 0 are notions that we could call token. Then the win and the draw, these are other notions. I have a winning condition, but that's a generic condition, and then I could have a result like 1 or a result like draw. And then if I simplify the board, this is again simplified. So these notions are in fact domain concepts. So when I want to write the tests, I want to see, okay, how can I write these tests so that I don't introduce too many concepts at once? If I would introduce too many, then my test would be difficult to understand, the refactoring would be weird, and it's very easy to do mistakes when you have so many new concepts in your test and in your production code. So simplifying the board makes me forget about it, because if it's one by one, I don't care about distances, placements, tokens, or anything. So while I simplify the problem, this makes sense. And it's the same with anything. So I can try to start with something that's very simple. So let's see. Now I will start with this, and I will try to write tests so that everything is very simple, and it could become even weird. What is the test I could write? The first test is for 1 by 1 board, X always wins. Why does this happen? Because I have X plays first, the board is 1 by 1, X plays, and X wins. That's simple enough. I will do something that's a bit weird, meaning I will start with the board. But for me, the board is a text. So I will write it like that. So in this condition, what I'm trying to do is assert that some expected value is equal to some actual value. Now the expected is that x1, and the actual value, well, I don't have it yet, because that's really the production code. I really want to respect this red green refactor. So now we are here in this red part. We've done thinking, we've done this analysis, we tried to simplify the game, we've done behavior slicing, and now we won't try to go to green. But first of all, let's make sure we are on red. So we run the tests, and we are on red. It says here expected x1, actual nothing. So this, in fact, this empty string is my production code result. So let me mark it like that. I would extract it to a variable, and I call this something like game result. If I want to implement this, it would look like if board is 1 by 1, then the result would be x1, otherwise it would be nobody 1. Let's see. So now I'm on green. I'm on green here. The test works. I want to go to the next step, refactor. So what could I refactor here? I want to make sure you understand why I have more than just a basic unit test. This is an arrange. This is the act. And this is the assert. These are the basic parts of a unit test. But I have this thing that exists here, and this is the production code. What I want to do now is write tests that would circle around this thing. In fact, around this thing, the fact that x1, and make sure I have enough tests to extract them, to extract this part of the code. And for this, I have another guideline. And it's called the rule of 3, which says only extract duplication when spotted at least 3 times. So my purpose now is to write more tests around this area to make sure I would have this identical production code in at least 3 tests, so that I could extract it and have my first method that was generated from these tests. For this, what I said, like going around this concept, this is another guideline. It's called triangulation. So triangulation says I would write enough tests so that I would understand what is this concept, what is this method, what is this production code. I need to have enough proof so that I understand it well, and the rule of 3 is a kind of a definition what is well, and the triangulation is just a way of trying to focus on this. So not trying to go now to, let's say, something else like draw or any other concept. Okay, I want to focus on this until I have it done. Okay, so I have my first test, it's running. Let me make sure it works well, run it again. And now I would commit, edit first test with board 1 by 1 and the and x wins. Okay, I forgot to add this. Great. Now what's the next test? I want to go on and triangulate on this concept. So again, I'm here, x finished, somehow, not necessarily on the line, but I'm focusing on the fact that x1. If I have a 1x1 board, well, it's clear that x will win. And I cannot have any other way because x plays first, so it doesn't make sense to say 0 plays and 0 1, because that would be against the rules. Another...
Stop coding now. Next episode will follow.
25 minutes passed. Apparently we'll do this
Stop coding now.
test.
Next episode will follow.
Episode, I will start a nice voice.
Stop.
So yes, thank you for watching. As I said, I get carried away with coding. Thank you for watching, and I hope I'll see you next time, and you'll see how this evolves into a nice code base, episode by episode. So until next time, have fun coding.